Now, this is the case too where I was mentioning earlier when we looked at the calculator. If you have the nice calculator, so two ways that, so I guess maybe three ways that I might ask you on the test to give me an answer. Number one, single logarithm. You could stop here. Second option, and this is again kind of just depends on what's asking. If I say go ahead and approximate a decimal, then you would go ahead and approximate a decimal. So these would be answer option number one, this guy, single logarithm. Option number two, approximate. So x is approximately, and then this is where you're going to say, go to math, log base, and just plug it in that way. So log base 6, 5, and we'll do 3 decimal places, 0.898. Now, let's say that I ask you, well, first off, let's say you get to this point, and again, I just use log base. I know you couldn't really see it, but maybe if I get a little closer here. There, if it'll focus. Come on. Yeah, you get the idea. There we go. Okay, so I use my calculator to approximate. Now, I'm not sure what the 83 says as far as log base, but if you don't have log base, then you're going to have to use option 3, which is use change of base. So if I've got log base 6 equals 5, if I use change of base, what I'm going to do is say log of 5. So what you're taking logarithms in the numerator, and again, I'm using the common log here as my common base. And then in the denominator, log base 6. So if I asked you for it in change of base form, that's what number 3 is. So you could have it as a single logarithm, you could have it as a decimal approximation, or you could have it in change of base form. Now for 2, you might need to use change of base depending on what calculator you have, because if you have a common log, and you have that on your phone, or you have it on, if you have a 34 or some of the more basic calculators, you're going to have a common log. So if you don't have it where you can convert it to with a new base, you can use a common log using change of base to get your decimal approximation. All right, let's see what else we got here. Let's do okay, I see 2 more I want to do. All right, let's say that we've got 5 times 10 to the 3x equals 24. Okay, so if we're starting here, and again, I'm pretty much every time I'm looking to convert between exponential and logarithmic. That's the preferred method if I've got something like this. Now to do that, we can't have anything outside. We just have to have this exponential function. So if there's anything added or subtracted to it, or in this case multiplied, we need to get that away from it because we need to isolate this exponential function in order to do the conversion. So it's easy as just using our algebra rules. We have multiply, we divide. So I've got 10 to the 3x equals, and now, again, you know how I am as far as rounding goes, that I don't like to round until I get to the very end. So you could put this as a decimal. If it's an easy decimal, like this is only 4.8. Okay, but if this was like a never-ending decimal, I would leave that as a fraction, to be honest. But for now, that's a nice decimal. We'll leave it there. Again, I would just look for what it's asking for. If it's asking for a decimal, be careful with rounding until you get to the end. Okay, so now that we've got exponential function equals a constant value, we can do our conversion. Start at the base, go towards the equal sign, back to the exponent. So I've got log base 10, not going to write it, common log, of 4.8 equals that exponent of 3x. So hopefully you understand we're not done yet because we still need to divide by 3, and that would be our final answer. So again, you could see this maybe there's probably only going to be 2 different ways here. You have x equals log of either 24 over 5 or 4.8, depends on what the question's asking for, over 3. That could be an acceptable answer if I asked you for an exact answer. Or you can do your approximation, say log 4.8 divided by 3. So 0.227. So we can have that as our decimal approximation. So again, it just depends on what the question's asking for. If it doesn't say approximation, you want the logarithm. Now, this is mainly for math lab, because if it's multiple choice, like at the exam, you'll be able to see right off what you're looking for. But if it asks for approximation, go ahead and do that decimal. Now this also works the same way for natural exponents and natural logarithms. So if we've got, let's say, 4e to the x plus 3 equals 8. So I see that e, and I understand that that is a natural exponential function, that I'm going to convert it using ln. Now again, to do that, we need to isolate this exponential function. So to do that, we need to subtract 3. And we need to divide by 4. So I've got e to the x equals 5/4, and that's an okay decimal. Again, I kind of like leaving it as a, just because I'm weird, as a fraction. Again, it doesn't matter, as long as you're not approximating a decimal until you get to the end, and it tells you to, I'm okay with it. So, converting exponential, starting at the base, it's whirling towards the equal sign. So log base e is ln. So ln of 5/4 equals x. So if I asked you to find the exact value, there's that. If I asked you to find decimal approximation, just do ln of 5/4. And that is approximately 0.223. So again, it just depends on what we're looking for as far as when we get to the, where we're finding our solution. Let's do one more of these, and then let's do some combining logarithms. Okay, so let's do one where we actually given a logarithm. So 7 minus 2 log base 5 of x equals 5. Okay, so again, I'm going to try to make this where I have a single logarithm and I can convert it to exponential, because that's kind of the way my preferred method. That's the word. So in order to do that, just like with exponential, we need to isolate this logarithm. So I'm going to subtract 7, and don't forget to keep this -2 log 5x equals -2. Okay, now I don't want this -2 coefficient out front. You could do kind of two things with it. You could use that bottom rule, but the easiest thing to do is just to divide it. So I've got log base 5 of x equals -2 over -2, +1. Now I'm in a form, since it's just a logarithm, I can convert it to exponential. So 5 is my base, swirl towards the equal sign. So I've got 5 to the 1 equals x. That was an easy one. There's no approximations here. Let's not write that 1. No approximations, it's just 5. So it's nice. Okay, so let's look at some examples combining logarithms. So if you look at 5.5 on the homework, it's going to start off with you having to combine logarithms and expand logarithms. To be honest, I will allow you to do that on your own, because if you can read these rules here, you should be able to compare them. If not, you have question help. I am more interested in using combining to solve for our log. I guess more worried about combining logarithms using them to solve. So let's So again, 5.5 is all about combining logarithms, all that good stuff. Again, I'm looking at the homework questions right now. Let's do one where we combine logarithms and we solve using our combination of logarithms. Here we go. Okay, so what I'm going to say to do, actually, let me do one thing before we do that. Because there is one rule we need to kind of, or one trick I should say, that we need to use before we can,
I guess, to make things easier when we actually combine them. So let's do one other thing before we get there.
all right, and this is from 5.6 from here on out. So I'm skipping 5.5 because it's just using those properties. Now this is for 5.6. So what we can do is if we have something like, let's just look at it here.
This is less of an example, more of a, here's how things work. If we've got, let's say we've got 5 to the x equals 5 to the 4th.
Okay, so now obviously you should be able to tell me that x is 4 because that would be the only way to make that equivalent. But what I want to do